Alright, we're going to go ahead and solve this system of equations using our reduced row echelon method and then learn a new method using matrices. So my first step is I'm going to rearrange by putting the bottom row up on top, and then we'll multiply the top row by -2 and add and replace our second row with that. That gives us -5 and -5, and then if I multiply by -1/5 on the bottom row, my form will look like. Okay, that tells me that y equals 1. If I plug that in up top here, 4 times 1 subtracted over 6 minus 4 is 2. X equals 2. So a solution of 2, 1. All right, if we look at the same system of equations and rewrite it as matrices, 2, 3, 1, 4, and then xy equals 7, 6. If we were to multiply across, we'd see we have the same system. So if we did 2 times x plus 3 times y, that'll equal the first row, first column element 7, and that's our first line. Second line would come out of multiplying similarly in the second row. So let's talk about this as a matrix. Call this matrix A. This will be our variables x and y, and then matrix B. Okay, so if we want to do some fairly basic algebra, we could know that we could undo the coefficient A here, it's a whole matrix, by multiplying by its inverse. And if we do it to one side, we can do it to the other. So A inverse times A gives us the identity matrix times xy. And the identity matrix times our variables just gives us our variables. So if we had a way in the calculator of multiplying the inverse matrix of A times B, that would give us our solutions x and y. Show you how to do that. We go to second inverse on the graphing calculator, go over to edit, we'll choose matrix 1. That's going to be our matrix A. That one's a 2 by 2. We key in those values. And then we create matrix B by doing second inverse, cursor over, and then make sure you choose a different matrix. We'll call it matrix B. And that was our 2 by 1, the 7, 6. Now I have in the system here, in the calculator, two matrices. I want the inverse of A, which is actually a bit more work than we want to deal with, but we're going to let the calculator do it for us. So once we've quit, we go matrix A, and we're going to do inverse, so I had x inverse again. So A inverse times matrix B, 2. If I hit enter, I get a solution of 2, 1. If you think about that from the previous problem, what we're saying is x equals 2, y equals 1. So this matrix system is, or matrix method is pretty useful, and we'll use it for the 3 by 3 matrix. So step 1 is to write a matrix equation. Step 2 is to multiply both sides by A inverse, which is to get the x, y, and z by themselves, and that's essentially how we solve it with a calculator. So in the graphing calculator, we're going to type in -4, -2, 5, 5, -4, -5, 3, -4, 6, and call this matrix A. Then we'll have our variable matrix x, y, z, and if you do that multiplication, you see we get this left side. That's going to equal 8, -14, 8. I'm going to set up in the graphing calculator matrix B. I can multiply A inverse times A, which also then A inverse times B, in the order that you write these matters. Then A inverse times A does equal the identity, and remember that identity times any matrix gets back itself, so we would just get x, y, z equals A inverse B. We can do that on a calculator. And so we do second inverse, get over to matrix A, And now I have a 3 by 3 entering these values for A. And then quit and go for matrix B. Now it's a 3 by 1. All right, now that we're set up in the calculator, we just do matrix A inverse, so 1, and then inverse it, matrix B. Hit enter, we get 0, 1, 2. That tells us that x is 1, or sorry, x is 0, y is 1, and z is 2.